this is Jo from Math Tutor Me. Hopefully you've been looking at my videos on surds and you're starting to feel pretty confident with simplifying surds, multiplying surds, adding, subtracting, expanding, all those things. Because if you're up to this stage, hopefully you know all those skills because these are questions that are designed to make you think a little bit. They're using all the skills that you've already learnt, but they look a little bit different, and the aim is that they want to try and trick you. So let's have a look at these questions today. Find the value of x and y if x plus y square root 2 equals 7 minus square root of 18. So what we want to do is to make this look like this side of the equation. To do that, let's look at the square roots. I have a square root of 2 on this side and a square root of 18. So I need to simplify this to make it look like that. So to simplify the square root of 18, I'm going to leave the 7 out the front. 18 is the same as 9 times by 2. Then I can split the surd. Okay, and then I can square root the 9, which is 3. So 7 minus 3 square root of 2. Now, this is square root of 2 and this is square root of 2, so I've got it in the right form. So now, the x is in the position of the 7, so x is equal to 7, and the y is in the position of the minus 3, so y is equal to minus 3. So I found the value of x and y. Let's do it again in question B. This time I've got x plus square root of y is equal to this very long and complicated thing here. To get this to reduce down to something like that, I'm going to have to expand out these brackets. So we're going to need to do our FOIL expansion. So F in FOIL stands for first, so the first thing in each bracket. 3 times 2 is 6, and square root of 2 times square root of 2 is 2. Then we do the O for outside. 3 times 5 is 15, and 2 times 3 is root 6. Then we want the inside. Minus 2 times 2 is minus 4. Root 3 times root 2 is root 6. And last, minus 2 times 5 is minus 10, and root 3 times root 3 is 3. Okay, we can times these. 6 times 2 is 12. These are like surds, so we can collect them up. 15 minus 4 makes a plus 11, root 6, and minus 10 times 3 is minus 30. 12 minus 30 makes a minus 18, and then the plus 11 root 6 goes afterwards. Okay, we've simplified it down quite a lot, but they're not quite the same. The reason they're not quite the same is in this, there is nothing at the front of this square root sign, but I have an 11 at the front here. So I still have to change this so that I can put this 11 back underneath the square root sign. So it's like the reverse of simplifying. To do that, 11 squared is 121. So I could change that 11 to be the square root of 121 times by the square root of 6. Then I could put those two surds together. 121 times 6 is the square root of 726. Now these are in the right form. So the x is in the position of the minus 18, and the y is what's underneath the square root sign, which is 726. And that's the end of that question. Let's see what else we have. Okay, in question 2 we are asked to expand out some brackets. Now that's normally not too difficult. But the thing that makes this question a little bit different is what we have inside our brackets here. So this is just a little bit more complicated than what we might be used to, having a square root of x minus 5. It's a little bit messier. So I'm going to do this showing all the steps that I can. So to do that, I'm going to write this bracket twice because it is squared, so it means the same bracket multiplied together twice. And then I'm going to do a FOIL expansion. You may find that you can do the shortcut method, and that would be excellent if you can. Okay, so doing the FOIL, we do first times first. Because they're the same, the square root signs are going to cancel out, and I'm just left with what's underneath, the x minus 5. Then I'm going to do the two outside terms. So the only thing at the front is the minus 2. And I need to multiply the two surds together. I'll simplify that a bit more on the next line. Then we do the inside, which is the one that is actually the same as the last one. And then we do last. Minus 2 times minus 2 is a positive 4. Square root x times square root x, the square root disappears and I just have the x. So I have an x minus 5. These two surds here are actually like surds, so I'm going to collect them. Minus 2 and another minus 2 makes a minus 4. And I can tidy up this square root sign, I can multiply them together to have x times by x minus 5 underneath the square root sign. And 4 times x could just be 4x. Then I can add together the x plus 4x, they're like terms, so that's a 5x minus 5. And the surd, I can't really do much with it. I can expand this bracket. X times x is x squared, and x times 5 minus 5x. And there it is, all expanded out. Alright, next question. If x is equal to 5 plus square root of 7 over 5 minus square root of 7, find the value of x minus 1 over x. Okay, this is a substitution question. We want to put this in for x. So I have x is this, minus 1 over x. Now 1 over something just means that you want to find the reciprocal of it, which means I just want to turn this upside down. So minus 5 minus square root 7 over 5 plus square root of 7. So now I just want to tidy that up, and to do that we like to have a rational denominator. So I'm going to rationalize each of these separately. The first one, to rationalize it, I need to multiply by the conjugate, which is the same denominator but with the opposite sign, so we'll have a plus in between. And then the second one, I want to multiply by its conjugate, which is the same but with the opposite, so this time a minus. So when I expand everything out, let's see what happens. So on the top, imagine that there is some brackets around here, or actually draw the brackets if that helps you. So I need to do first, 5 times 5 is 25. Outside will be 5 times root 7, 5 root 7. Inside is another 5 times root 7. And last, root 7 times root 7 is 7. On the bottom, 5 times 5 is 25. Now the reason we multiply by the conjugate is because we know the middle two terms of our expansion will cancel out. So we can skip those and go to the last terms. Minus root 7 times plus root 7 means I will get a minus 7 because the square root signs cancel out. Now let's expand out this term over here. 5 times 5 is 25. 5 times root 7, or minus root 7, so it'd be minus 5 root 7. And then I have minus root 7 times 5, so minus 5 root 7 again. And minus root 7 times minus root 7 makes a plus 7. Expanding the bottom is actually the same as this one. 5 5s are 25. Middle terms will cancel out, so root 7 times minus root 7 makes minus 7. So I actually have the same denominator here. 25 minus 7 is 18. So both of these have a denominator of 18. So I can push them together and collect up some things on the top. I have 25 plus 7. So let's make that a 32. I have 5 root 7 plus another 5 root 7. That's a 10 root 7. Now be careful here when you have a minus. I need to expand that minus into the top of this fraction here. So what I might do it in two steps. I'll put the minus sign there and I'll put a bracket. 25 plus 7 is 32. Minus 5 root 7 minus 5 root 7 is minus 10 root 7. And on the next line I will expand that minus through. You've always got to be very, very careful with minus signs and fractions like that. So that will become a minus 32 and a plus 10 root 7 when you expand that through. So 32 minus 32 is nothing. 10 root 7 plus 10 root 7 makes 20 root 7 over 18. That's a pretty nice answer, but you can actually divide both of those by 2 to make it even simpler. So it'd be 10 root 7 over 9 would be your final answer. Okay, so I have one question here for you for practice time. So if you want to grab your pen and paper, pause the video and have a try of this question, and then we'll go through the answer together. Okay, let's go. It's very similar to the last question that I did. We have two fractions here involving surds that we need to simplify to become a nice, simple expression here at the end. So to do that, I'm going to have to rationalize each of these and collect those two fractions together. So rationalizing each one separately, my first fraction, just writing it down again, and I'll multiply it by the conjugate, which is the same with the opposite sign over itself. Okay, then the second fraction, write it down, and multiply by its conjugate, which is the same with the opposite sign. Okay, so now we want to expand each of those out. So the first one, doing the FOIL expansion, root 3 times root 3 is 3. Then do the outside, root 3 times root 2 is a positive root 6. Root 2 times root 3 for the inside is another root 6. And last, root 2 times root 2 is 2. On the bottom, root 3 times root 3 is 3. The middle terms will cancel out, so the last ones are minus root 2 times root 2 makes a minus 2. Okay, expanding the second one. First is root 3 times root 3 is 3. The outside, root 3 times minus root 2, minus root 6. Inside, minus root 2 times root 3, minus, which is minus root 6. And last, minus root 2 times minus root 2 makes a positive 2. Square roots cancel out. On the bottom, first is root 3 times root 3 is 3. Middle terms will cancel, so last will be root 2 times root 2 makes minus 2. Now 3 minus 2 for both of these is actually just a denominator of 1. So I really don't have a denominator left at all. So all I need to do is collect up a few things here. Again, be careful because we have a minus sign. So let's do each fraction part separate. 3 plus 2 is 5. Root 6 plus root 6 is a 2 root 6. Now I need to have a, let's expand the minus through. So it'll be minus 3, minus and a minus will make that a plus root 6, plus another root 6, and a minus 2. So that minus is changing the sign of everything across the top there, which means I can collect that up with some of these things up here. 5 minus 3 minus another 2 is 0. That's all gone. 2 root 6 plus another root 6 plus another root 6 makes 4 root 6. So let's have a look. This is my answer that I've simplified to. If I go back to my question, I have something root 6. Well, I have something root 6 and my something is a 4. So that means therefore my answer is P is equal to 4. And that's the end of this section on surds. I hope you have had fun doing these questions, and I want to encourage you to keep practicing, do as many questions as you can find, and I'll see you next time for my next video. Bye!